Different car companies use different forms of all-wheel drive. In a certified independent test, we chose 5 vehicles within the same class to see how those different forms of all-wheel drive transfer power. In this specific ramp test, the 2 front roller mechanisms and left rear rollers are freewheeling to simulate slippery road conditions, offering virtually no traction. And by covering the right rear rollers, we leave that as the only source of traction. The driver will maintain constant pressure to the accelerator, and once the wheels slip, each system should direct enough power to the right rear wheel to climb the ramp. First up, Nissan and its intuitive all-wheel drive system. In the intuitive all-wheel drive system, power is flowing to all wheels, and we can see it trying to shift more power to the right rear wheel, but it's not enough to move the vehicle forward. Next up, Honda and its real-time four-wheel drive. Now, this is a front-wheel drive-based all-wheel drive system, where all the power is in the front until it detects slipping. And only then is it transferred to the rear wheels, but there's clearly not enough power to climb. Let's see how Ford and its intelligent four-wheel drive does. The driver is maintaining constant pressure to the accelerator, but the vehicle appears to surge as it tries unsuccessfully to send power where it's needed most. And did you notice the side-to-side movement? That's called torque steering, and is often due to an asymmetrical drivetrain, where the left and right front axles are different lengths, and the driver has to fight that torque to keep the vehicle in line. How about Toyota and its on-demand four-wheel drive? As in all these vehicles, the driver is maintaining constant pressure to the accelerator. But listen, the engine speed changes as the system tries to take control from the driver and transfer power to the right rear wheel, but there is not enough power to provide the traction it needs. Finally, let's look at Subaru and the symmetrical all-wheel drive system. With power flowing continuously to all wheels, it senses the loss of traction and sends more power to the right rear wheel, allowing it to find its grip and move the vehicle up the ramp. This is a unique test, but by focusing on one wheel, we can clearly see how different systems react to a loss of traction and where their power is actually transferred. Ideally, an all-wheel drive system should be able to direct power where it's needed most. Symmetrical all-wheel drive does exactly that, and this system is standard in every Subaru vehicle.